Hello and welcome back to Python, back to Numpy with our third video now about byte arrays and the difference between big and little endian. This is, by the way, a video you can kind of skip, so you can skip to the fourth part because most of the time it doesn't matter which byte order is used if you don't alter the default byte order. So if you don't set the byte order, you won't have any problems in general. But if you're more into binary data serialization or file formats and using binary file formats, knowing something about byte order or even how to specify the byte order in Numpy arrays can be useful. So watching this video won't make you dumber or more stupid, I guess. Okay, but what is a byte order? Byte order is the order in which individual bytes of multiple byte data types, integers, floats, stuff like that are stored in your memory. And yeah, it depends on the byte order how a computer represents and interprets the bytes. For example, there are two common byte orders, the little endian and the big endian. And if we are using an AMD or an Intel processor, it will most likely be the little endian byte order. This simply means that the least significant byte is stored at the lowest memory address and the most significant byte is stored at the highest memory address. And yeah, big endian, it's the exact opposite, so the most significant byte is stored at the lowest memory address and the rest you can think it's obvious. So in Numpy you have the byte order attribute and you can check the byte order of your Numpy array, or you can even specify the byte order. But usually it uses the byte order of your system by default. And let's just have a look how you can get the byte order. So we have our array, which are the numbers 1, 2, 3, or 23, 4, 56. And if we type in r.dtype point byte order and we want to print it, it will give us an equal sign, which means the native byte order of your system is used, which is in most cases the little endian. Okay, now we want to create our or specify the byte order. As already told, you can dtype, you can specify your dtype, for example, an integer with 4 bytes. And if we are using the sign, we will define the byte order. Now we are using the native byte order. Let's print the array, by the way. And yeah, we are getting our equal sign because we said it is equal I4. And this will get also the equal sign because our system uses little endian. And now we are using the big endian because, yeah, greater than means that the big order endian should be used. So to get rid of any confusion, of course, the array will always be the same. The byte order just defines how the bytes are stored, not how the certain array is presented. So the content will always be the same no matter how the byte order is. Yeah, this was a kind of short guide or tutorial. It was just some minor topic I didn't want to skip. And yes, I wish you a wonderful evening, night, day, dinner time, whatever time it is. See you in the next video, and bye bye.